Most of what we do today should look very, very familiar. Because all we're doing is we're taking the steps and the process that we have already done, and we are just attaching some different formulas to that same process. And the idea of what we are doing is mostly if, let's say we have two different treatments in an experiment, and we want to compare parameters within those two separate treatments. So the big difference in what we're doing in chapter 10 is that we are now, instead of looking at one sample, we are looking at comparing two different samples. And so that's going to be the big difference between the two. So we're going to look at comparing two different samples. And we have like P1 and P2. We have this, remember the statistic, we use P hat for them instead. And we're going to use 1 and 2 as a subscript to tell each of them apart. This is where it's going to be really important to define our variables in that step 1. Because when you say P1 and P2, you need to be specific about which one is P1 and which one is P2. So we already know that with one proportion, we have the mean is P, standard deviation is the square root of P times 1 minus P over N. So let's start with an example, and we're going to walk through kind of a step-by-step process of how this is going to look for a specific example. All right, so let's say we have two schools where we are trying to figure out the difference in their homework completion from last night. And we have 70% of school 1 and 50% of school 2. And so our variable that we're going to be interested in is basically the difference of homework completion between school 1 and school 2. And so we're going to make P1 be school 1 and P2 be school 2. And what we're going to talk about is what the difference in the proportions are. This is kind of building our formula. That's what we're about to do here. We're going to talk about where the formula comes from. So we have, here's the percentage of, for samples from P1. Here's the samples that we could get from P2. Here's the samples we could get from the difference. First off, you should know that these are approximately normal. And then you have your center and spread here as 0.2 and 0.058. Now, the question that we're going to have is, how can we calculate this center and spread? Our mean of the first one is 0.7. Our mean of the second one is 0.5. And so remember that what we're doing here is we're subtracting two different variables. And we already learned how to get mean and standard deviation when we're looking at a distribution of subtracting two variables. So that's what we're going to look at here. If I have two variables that I'm subtracting, the way that I'm going to get the mean of that is that we are going to subtract the means. The mean of the difference is the difference of the means. So in that case, we would have the 0.7 minus 0.5 would be 0.2. And that would be the mean of the difference. I would just take my 0.7 and 0.5 and subtract them to get 0.2. The standard deviation, remember when we have two separate variables, we talked about this. The standard deviation is going to involve adding variances. So that means we need to get the variance of these distributions. Well, remember that standard deviation for P is square root of P times 1 minus P over N. And so how do I get the variance there? I get the variance by squaring the standard deviation. Take it and square it. And so when that happens, I get no more square root. Again, you will not need to memorize this process. We're just talking through where the formula comes from. Just kind of reminding you a big picture here. So in this process of adding the variances, what's going to end up happening it still thinks I'm erasing. There we go. So that's the mean. Here's the work for adding the variances. The variance of one plus the variance of the other. So here's my variance, my total variance. And then the standard deviation is my square root of the variance. So I'm going to take this square root of the variances added together. And that is my formula for standard deviation there. This formula is standard error for two proportions. It's on your formula sheet. You would not need to memorize this formula. I'm just showing you that it's coming from the fact that for standard deviation here, we add variances. And that's how this kind of gets constructed here. So, shape. We're going to use approximately normal as long as our n times p and n times 1 minus p are both at least 10. Center, the mean of the difference is the difference of the means. Spread, the standard deviation, we would add the variances. So the distribution is going to look like this. So when we make our formulas, when we put in our place the statistics and the means and the standard errors, these are the formulas that are going to go there for mean and standard error this time. So, what we're going to look at first example here. We're going to start to look at a hypothesis test, what a hypothesis test is going to look like for this distribution. Okay. At school 1, 70% of their students did homework, 50% of the students at school 2 did their homework. So we're going to plug values into this formula. So first off, if we want to know if these two things are normal, we talk about shape, center, and spread. First, we want to talk about shape. The key thing here is that we need to check normal for both of these proportions. So basically, we're going to end up checking normal twice. We're going to check n times p and n times 1 minus p for school 1. And we're going to check n times p and n times 1 minus p for school 2. So that should look like this. For school 1, there was 100 students sampled, and our P should be 0.7 for school 1. So that's our N times P. N times 1 minus P is 100 times 0.3. In school 2, we have 50% of the students, and we took a sample of 200. So that's what we're going to use for our N times P and our N times 1 minus P at school 2. But we are checking it for both schools. For both P1 and P2, we are checking N times P and N times 1 minus P for our normal condition. Nothing here should be new. It's just adding a little bit of layers to some of the conditions that we check, the way that we state certain things and variables, and the formulas are going to get a little bit more complicated. But all the ideas and the steps that we're about to do are going to be the same as they were. Center, the mean of the difference is the difference of the means. And then here's your standard deviation formula. Again, it comes from adding the variances. But this standard deviation formula would just be in your formula sheet. P times 1 minus P over N for the first, plus P times 1 minus P over N for the second. That adds the variances. And then to get from the variance to the standard deviation, we take the square root of all to get 0.058. So that is basically our part A. This is going away in about 15 seconds. Again, the formula this comes from is the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. And then we're plugging in our values. That's the standard deviation formula. So now we have a normal distribution with the mean and standard deviation. So basically what we're about to do in part B is would be computing a p-value. That's basically what we're about to do. But we're going to frame it as normal distribution, getting the z-score, doing normal CDF. So let's take a look at that. Find the probability of getting a difference in sample proportions of 0.1 or less from the two surveys. So here's what your normal curve drawing would look like. Mean is 0.2, standard deviation is 0.058, so we go 0.058 is our scale on either side. And we want the probability of getting 0.1 or less out of my sample. Again, this is basically what you are doing when you are computing a p-value. You would get the z-score from the sample minus our mean of the difference over the standard deviation. We just did those long and complicated parts of the formula in part A. But this is a z-score, value minus mean over standard deviation. And then we want everything to the left of this z-score. So if we were to do normal CDF, our left bound would be the really low number. Our upper bound would be the negative 1.72, since we want everything to the left of it. And we get 0.0427. So if we were doing a hypothesis test, this would basically be our p-value. And so our answer for part C is basically going to be our interpretation of a p-value. We're going to phrase it as, there's only a 4% chance of getting this. This seems suspicious, but eventually we're going to get to this p-value of 0.0427 is less than our alpha level 0.05, which means we reject the null hypothesis, and we're going to conclude the alternative that the difference is less than 0.2. Right, so what I'm doing here is giving the setup for what we're going to use for formulas for our confidence intervals and hypothesis tests. That's what we are showing here. I'll leave this up for about another 30 seconds. The biggest thing to get from this is that this part B is basically how the p-value is going to get calculated when we get there. We'll do hypothesis tests more formally when we come back on Tuesday. For right now, we are going to do, we're going to end by doing a confidence interval and showing you what a confidence interval is going to look like. All right, here we go. Remember, this is the way that this formula is going to look on your formula sheet. Right, this is how the formula is going to look on your formula sheet. And based on the formulas we just talked about, we're going to have to get from here to the formula for this particular confidence interval. So how are we going to do that? Well, the statistic is going to be the difference of proportions. What's the critical value going to be? Well, since we're using proportions, then our critical value is going to be a z-score. And we're going to get the z-score for our confidence interval the same way we did 2 chapters ago. And then the standard deviation of the statistics, since we're using 2 proportions, we'd look on our formula sheet and look for the 2 proportion part of the formula sheet. Or we'd think about adding our variances. And we would just get this formula. That's how this formula is getting built. There's my statistic, there's my estimate, plus or minus my critical value, which is my z-score, times the standard error formula. Well, the standard error formula is this. A couple details. Remember that with confidence intervals, we're using our sample the whole time. right? There's no null hypothesis. There's no P naught to be using because we're not having a null hypothesis. So these are all P hats. Make sure that you're using ones as subscripts here and twos as subscripts here to tell them apart. And then make sure that they're separated by a plus sign here because we're adding variances. So the formula is going to come up on the board again here. But I would just wanted to show you how that formula, how you would take this structure that is on your formula sheet and build that formula. Do not try to just look at this and memorize it. Too complicated. Be able to go from here to filling in the missing pieces that would go in each of these spots. That's what you'll want to do. So, four-step process. Let me outline what it's going to look like. Step one, you're going to state out the confidence interval you're trying to find. So that's going to look like, we're using a 95% confidence interval to estimate this difference in the two proportions. You're going to define, here's what my P1 is and here's what my P2 is, to make sure you're saying which one is which. So state your confidence interval, define your variables. Step two, you're going to say the name of your test, which in this case would be a two proportion. So now we're using two proportions instead of one proportion. Z scores, interval. We're doing a confidence interval. So this one is called a two proportion Z interval. And then we check our conditions. Guess what? They're random, normal, independent. Random, we need to check that each of our data comes from random samples, or there might be some random assignment in an experiment. Normal, we need to check n times p and n times 1 minus p for both samples. And then we need to check independent in each case. So we're checking the same conditions, we're just doing it for both samples. Step three, you're going to make your formula, plug in the numbers, answer. You're going to go to your calculator and go to two proportion Z interval to get the values out of your calculator. And then step four, you're going to interpret. We are 95% confident that the actual difference in these proportions in the context of the problem is in between these two values. That's how this four-step process is going to work. All right. Social networking sites, whatever those are. We did two surveys. One moment. Here we go. We're constructing and interpreting a 95% confidence interval for the difference between the proportion of all US teens and adults who use social networking sites. So we're figuring out how different is the disparity between teenagers and adults in how many of them use social networking sites. My suspicion is that this gap has narrowed since the time this 2009 when this was conducted. They may use different social networking sites, but my guess is that do you use social networking sites is closer together than it was in 2009. Regardless, step one. We are using a 95% confidence interval, and then we are defining, we're estimating P1 minus P2 And we're defining which one is which. It doesn't matter which one you make P1 and which one you make P2. What matters is that you say specifically which one is which. In this case, we're going to make P1 the teens and P2 the adults. Again, the important thing is that you say which one is P1 and which one is P2. So that's your step one. Say that we're doing a 95% confidence interval for P1 minus P2. Define what P1 is, define what P2 is. Step two. Again, it says a 2 sample Z interval for proportions. I'm going to change that to a 2 proportion Z interval because that matches what the calculator is going to be. That matches the one you're going to be looking for in the calculator. So this is a 2 proportion Z interval. I want to give you about 2 minutes and see if you can write down what the conditions are and have them checked. Remember, you're basically checking the conditions for both samples individually. So I'll give you about 2 minutes to try and do that. Okay, let me talk through each of them. Random, normal, independent. Random. The part that's random about this, that you're looking for, where are they random? Well, there's a random sample of 800 teens. We have a random sample of 2,253 adults. There's your random condition. So you'd write those down, and you got them. Normal. You're doing n times p and n times 1 minus p for each of them, and you're checking that each of them are at least 10. And then for independent, since they're 2 separate samples, you should take 10 times each of the sample sizes. More than 8,000 US teens, more than 22,530 US adults. And there's our random, normal, and independent conditions. Here's what those look like. I'll keep them up for about 30 seconds. Hopefully you shouldn't have to fix too much. Remember that it's n times p hat and n times 1 minus p hat for each of them, because we are using the sample here. That's different from the hypothesis test when we were using the null hypothesis. With confidence intervals, we are just estimating with our p hat, which means that we're checking n times p hat and n times 1 minus p hat in our step 2. I would be putting this. And then say, these are all at least 10, so we can use an approximately normal distribution. That's our random, normal, and independent. All right. Moving forward, we're going to be doing formula, plug in the numbers, answer. Now, the biggest thing that you're going to need is remember that with proportions, it's going to ask for x and n. So it's going to ask for x and n in each of these. So that means how many out of how many in total? How many did we have in the sample out of how many in total? And so how many we had in the sample, we don't want to put our p hat, we want to put our number in the sample. So that's 584, for our teens and 1,059 for our adults is the number of them that use social media. So that's what we're going to put in when we go to put these in the calculator. So 1 was the teens, so X1 is going to be 584, and X2 is going to be 1,059. That's just a note for when we go to the calculator. You'll see that when we do it. But what to write down? Formula, plug in the numbers, answer for step 3. There it is. Again, it's a complicated formula, but it just slots the formulas for 2 proportions into the general confidence interval formula. So while you look through that and write that down, let me show the calculator. Stat, over to tests. You want to look for, not tests, this is not 2 proportions Z tests, this is a confidence interval. So we're going to keep scrolling down to a 2 proportion Z interval. 2 proportion Z interval. Here's our X and N. So our X1 was 584, and that was out of 800. Our X2 was 1,059. And that was out of how many? 2,000 something? Thank you. We're doing a 95% confidence interval. Here it comes. P hat 1 was 0.73. P hat 2 was 0.47, basically, because we rounded the n times 1, n times p there. And then here were our sample sizes. Here's what the confidence interval gives me. So this is my confidence interval. And hopefully, by now you know what you need to write in step 3. You need to write down formula, plug in your numbers, answer in step 3. So there is my confidence interval. And then in our step 4, we are going to finish with our usual step 4 sentence. I am 95% confident that the actual difference in proportions of teens and adults that use social networking sites is between these 2 numbers. Or in terms of how the book writes it, this is how the book writes it, this first sentence. And then the second sentence isn't necessary. It's just elaborating to make sure you understand what the confidence interval is we just found. But remember, the 3 key parts of that sentence, you want to have the phrase 95% confident. You want to say what your parameter is. Again, hopefully you had done that in step 1 and can just copy it over. And then you want to say that that parameter is between these 2 numbers in your interval from step 3. It's the exact same sentence that we had already done. So what we're going to do on Tuesday is we are going to take these ideas and apply them, these same formulas and these same ideas, to hypothesis tests. And really, on top of this idea, there's really only going to be one major change that we're going to make to the hypothesis test. Otherwise, everything is pretty much going to be the same. So there's one more main idea we have to talk about and build upon. I'll come back to this in just a second, but your homework assignment is there. I've already posted it on Canvas. This is the 10.1 homework. Remember, what you're going to have for homework for this chapter, you're going to have a book assignment for 10.1. You're going to have a book assignment for 10.2. So this is a book assignment for 10.1. You're going to have a set of free responses, packet of free responses, which I hopefully handed to all of you. The one that is about 10.1 is free response number 4. There are 5 in total on that packet. The 4th one is one that you should be able to do with the proportion stuff that we talk about over this time. The rest are talking more about means. So we'll cover those when we get back from spring break. But that is your first assignment to kind of be starting to work on.